My screen is visible to you?
Yes, sir.
So we will be starting our new next topic, that is decoders. So what are decoders? It is a logic circuit that converts n-bit binary input code into m output lines such that is activated for each one of the possible combination of the input. So it is a logic circuit that converts n-bit binary input code into m output lines such that only one output line is activated for each one possible combination of input. Am I audible properly?
Yes, sir.
Okay, so it is a logic circuit that converts n-bit binary input code into m lines such that only one output line is activated for each such possible combination of input. For example, if I want to draw a block diagram of a decoder, you can say that we are having here n input lines, you can see, and m output lines. Right, n input lines and m output lines, and only one output line will be enabled. One means either this can be enabled, this can be enabled, this can be enabled, or last one can be enabled, depending upon the suitable combination of the input. For example, if we are having two inputs, maximum output line we can obtain is 2 to the power n. That is, we can have 2 to the power n combinations, right? So maximum output lines can be 2 to the power n. So maximum output lines can be 4. So 2 to 4 decoder is having 2 input lines and 4 output lines. Similarly, if input is equal to 3 binary bit, so output lines can be, maximum possible of combination of input can be 2 to the power n. That can be represented by 2 to the power 3. So that means 8 lines. Right. So this is called as 3 to 8 decoder, where we are having 3 input lines and 8 output lines, and so on and so forth. It will go on. So in general, if I want to write, if we are having n input line then we can have 2 to the power n combinations output lines. That is, output lines can be equal to 2 to the power n or will always be less than 2 to the power n. Output cannot be greater than 2 to the power n combinations of input lines, right? If you are, for example, if you are providing 4 input lines, maximum possible output you can get is 16, right? You cannot get 17 or more, right? 16 or less than 16 output you can get for 4 input lines. So this is the general formula. If you are having n input lines, maximum output lines you can have is 2 to the power n. Now serially we will see how can we build the decoder or the decoder logic. So first one in this will be 2 to 4 decoder. So in 2 to the power 4 decoder, if you want to draw the logic, just a block diagram here. So 2 to the power 2 to 4 decoder. Here we are having 2 inputs, A and B, and correspondingly we will have 4 outputs. That is, you can call it as D0, D1, D2, and D3. So for 2 inputs, we are having 4 outputs. Now, if you want to build the truth table, AB, value can be have 0, 0, 0, 1, 1, 0, and 1, 1. Correspondingly, we will have here D3, D2, D1, and D0. Now, if both A and B are 0, D0 will be high, and all the lines will be less. So you can see for only one output line will be high from the definition. If you want to see, only one output line will be high or activated. High means activated for each one possible combination of the input, right? So for this 2 to the power 4 decoder, if you are having 0, 0 at the input, then this D0 line will be activated or it will be high. So you can see in the truth table as well. For 0, 1, D1 line will be activated, 0, 0, 1, 0. For 1, 0, D2 line will be activated. For 1, 1, D1 line will be activated. So you can see for each possible combinations of input, one line at a time will be high. If you want to build this, so let me draw A here. So this is, let us suppose, A line, and this is B here. This is the line for B. I can take a NOT gate and invert this. I can take a NOT gate and invert this. Right? Now see here, what is D0? D0 is 1 when both A and B are 0. So this is A and B. So I can take A bar, B bar. So I will take one combination from A bar, and this is B bar, and I can pass it through an AND gate, and this will be equal to D0. Secondly, if you see D1, for D1, A is equal to 0, B is equal to 1. A is equal to 0 means I can take it from here, and B is equal to 1, that means I can take it from here, pass it through AND gate. This will be equal to D1. Next will be D2. For D2, you can see here, A is equal to 1, B is equal to 0. A is equal to 1, I can take it from here, and B is equal to 0, I can take it from here, pass it through here. So this will be D2. Finally, A3, A1, and B1. So I can take A from here and B1 from here, pass it through AND gate. So this will be equal to D3. Now this is the logic circuit for 2 to 4 decoder. So a 2 to 4 decoder is having 2 input lines and 4 output lines. So that is why it is called as 2 to 4 decoder. You can see here. Now for each possible combination of input, we are having only one output line activated. So here you can see for 0, 0, only D0 will be activated, rest all will remain 0. For 0, 1, only D1 will be activated, rest will remain 0. For 1, 0, only D2 will be activated, rest will remain 0. Similarly for 1, 1, only D3 will be activated, rest will remain 0. If you want to see this logic circuit, so this can be that. Now we are having one more circuit which is called as 2 to 4 decoder with enable. Enable, as the name suggests, it is acting like a switch here. You are having 2 to 4 decoder as usual, where you are having 2 inputs. You can say A and B, and 4 outputs. You can name them D0, D1, D2, D3. And apart from this, you are also having one enable switch here. You can call it as E, right? Now, you can see here this enable, when you provide 1 to this enable, when enable is equal to 1, then only this decoder will come into the picture, right? If E is equal to 1, then only for suitable combination of input, you will get the desired output lines. If E is equal to 0, that means if the enable is low, then this whatever combination you provide at the input, you will not get the output, right? So E is the enable. Here, if E is high, then only you will get the corresponding output. If E is equal to low, you will get output. You can write here. If E is low, that is, if this enable is not high, that means this decoder is not on, then you will not get output, right? For any combinations, you can say. For example, now if I want to write here enable as well, right? If I want to add one more column here, like enable, and so enable should be high in all the cases, right? For getting the output lines. Now, when enable is low, you can say when enable is low, then for any combinations, cross means we do not know. So I can write cross here. For any combination of A and B, we will not get any output. Is it okay? Just see. Now, if you want to see this in logic, so what I can do, I can write here E, and I can have its line as well. And I can pass this E to AND gate here, all the AND gate. Now, whenever this E is equal to 1, then only this will pass to an AND gate. And in AND gate, you can see here in AND gate, all the input should be 1 to produce your D0, right? So if E is equal to 0, this output of AND gate will always be 0, you can say. So therefore, this E should always be equal to 1. Is it okay? So this is the logic circuit for with enable, and this is a truth table with enable. You can see, and this is the block diagram with enable circuit. Just check, is it okay or not? Tell me. Am I audible?
Yes, sir.
Okay. So is this okay? Or you are having any doubt? Anyone? Should I explain it again?
Sir?
Yes. Should I explain it again?
No, sir. Sir, in diagram, if E is equal to 0, sir,
E is equal to 0, then all the output D0 to D3 will be 0, because you can see E is passing through an AND gate. In AND gate, if any one of the input is 0, then output is always 0.
Okay, sir. Okay.
Right?
Yes, sir.
Is it okay to everyone?
Yes, sir.
Okay. So now this is 2 to 4 decoder with enable. Now there is one enable as well, which is called as active low enable. Active low enable. This kind of enable is called as active high enable. Active high enable. Active high means this decoder will be operated when your enable will be high. Now in active low, just a reverse case for active high. In reverse case, what you can say, if we are having 2 to 4 decoder, we can have 2 input, 4 corresponding input, and here we are having an active low. So how to show the active low? You can show by a circuit or a bubble here. This is the representation for active low. In active low, you can say that we have represented it by a bubble. So you can say here active low. Now, what is the difference between active high and active low? That means here E should be 0 to operate this circuit. Here E should be 0. If E is equal to 0, then only your output lines you will get. If E is equal to 1, that is, if enable is high, you will not get output signal. You can write here. No output signal. Right. Now, if you want to draw this logic circuit for this low enable, what you can draw? A, B, as we have drawn for our previous case. We are having our NOT gate. Then we are having our NOT gate. We are having enable as well. And we are having invert of enable. Now, for first case, A is equal to 0, B is equal to 0, A bar, B bar, and E bar. This will be equal to D0. So, you can see here, whenever E is equal to 1, whenever E is equal to 0, then only this AND gate will produce an output. Because when E is equal to 0, the output of this NOT gate, this will make it 1, and this will flow to the AND gate. Now, for next combination, A bar, B, and E. This will also pass through an AND gate. This will be D1. So here also you can see we are having, when you will get D1 whenever this E is equal to 0. When E is equal to 1, then you will get here 0. And when 0 is passed through an AND gate, the output will be low, or you will not get the output. Then we are having A B bar. So this is A, and this is B bar, and this is E naught, E bar. So this you can call it as D2. Similarly, you can get D3 as well. So for D3, A is equal to 1, B is equal to 1, and this is E bar. This will be D3. So this is called as active high as well as active low enable. Just for your reference, I'm telling you one again, just a block diagram view. So 2 to the 4 decoder. We're having 2 inputs, 4 outputs. Again, 2 to 4 decoder. 2 inputs, 4 outputs. Now, if I provide here directly E, and if I provide here E bar, so you can see here we are having a circle. So this will be active high enable. Two to 4 decoder, and this will be active low enable. 2 to 4 decoder. Okay. So this is regarding 2 to the 4 decoder. Similarly, you can have 3 to 8 decoder. In 3 to 8 decoder, you can say it active high enable with active high enable. If you want to provide enable circuit as well. So in 3 to 8 decoder, you are having 3 input. You can call it as A, B, and C. And then you will get 8 output, 4, 5, 6, 7, 8, right? Starting from D0, and it will end till D7. So this is 3 to 8 decoder. active high enable, that means you can give here E. Now for this you can draw the circuit by your own, where you are having A, B and C. You can draw the truth table, and then you will have D0, D1, D2, D3 till D7. Now for each possible combination of input, a particular output bit will be high. For example, for one case I will tell you, if A, B, C are 0, then D1 will be high and rest all will be 0. If B, then if you are having 0, 0, 1, then D1 will be high, that is 0, 1, 0, 0, L will be 0. Similarly, for last case, that is 1, 1, 1. For this combination, D7 will be high, that is 0, 0, 0. All will remain 0 and only D7 will be high. Now for circuit, logic circuit for this, you can draw A, B and C. You can stretch a line here. You can get an invert gate. You can get an invert gate. You can get an invert gate from here, and you can draw. For example, for first case, when A, B, C both are bar, but both are 0, all of them are 0. So I can take it A bar from here, B bar from here, C bar from here, and enable is also there. Enable is equal to high, and enable is from here, and pass it through an AND gate. So this will be equal to D0. Are you getting the point?
Yes, sir.
Yes, sir.
Okay. So this is regarding the 3 to 8 decoder with enable high. Similarly, you can have 3 to 8 decoder with enable low. Only difference there will be that circuit will be only high when enable will be low. So for that case, you can pass through an invert gate and pass all the signals to the AND gate here. Right. So enable high, enable low will be there. Now we will see some problem statement. So the problem statement is realize 2 to 4 decoder using 1 to 2 decoder using both active low and high enable. So you can see what you have to realize. Ultimately you have to make 2 to 4 decoder, but you are only having 1 to 2 decoder. This is the limitation, right? With you, so how many 1 to 2 decoder will be required to make your 2 to 4 decoder, that we have to see. And two conditions are given. You have to use active low as well as active high enable. So two different circuits will be there. So let us just draw the truth table. So A and B, 2 to 4 decoder we want. So that means we will have D3, D2, D1 and D0. That is 4 possible combinations will be there. Possible combination will be 0, 0, 0, 1, 1, 0, 1, 1. So for 0, 0, D0 will be high. For 0, 1, D1 will be high. For 1, 0, D2 will be high. For 1, 1, D3 will be high. Rest for all the cases, all will be 0. So this will be the truth table. So you can see here, you want 2 to 4 decoder, but right now in problem you have given that you are only having 1 to 2 decoder only. So what you can see here both A are 0. In first case you can divide this, and you can see that the input A is remaining 0. In first case, first two inputs A is 0 and last two input A is 1. So by using this, first we will draw with active low, and then we will draw with active high, right? So let us suppose we are having 1 to 2 decoder. We are having only one input, and we are having, so for this one input there will be corresponding 2 output. Similarly, we can use 1 to 2 input, 1 to 2 decoder. For one input, we are having 2 corresponding output. Now let us first consider an active low case where you are having E bar here E bar, and you can see for first case is that when A is equal to 0. Second case when A is equal to 1. So what you can do, you can name this as B variable or B, and you can have an A here and pass it through this, and use an invert gate and pass it through this. So whenever A is equal to 0, so if you want to see whenever A is equal to 0, 0 will flow here. So this is active low. This will get activated because this is active low. In active low, you should get 0 at the enable to activate this. So whenever A is low and B can have two values, that is 0 and 1. So whenever A is low and B is having and B is 0, so you can get D0, and when B is 1, you can get D1. Similarly, when A is 0, you will get here 1. When A is equal to 0, you will get 1. So then, therefore, this second decoder will not be activated because you have to get 0 here. Now, for second case, when A is equal to 1 here, you will get 1 here. Then this decoder will not be activated because this is high enable, and here you will be getting 0 because we are having a NOT gate here. So when A is equal to 1, you will get 0 here, and you will get 0 here. Then this decoder will getting activated. So when A is equal to 0 and B is equal to 1, you will get D2. When A is equal to 1 and B is equal to 1, you will get D3. So this is how you can get 2 to 4 decoder. So this is the circuit for 2 to 4 decoder using 1 to 2 decoder. Right now we have used enable low circuit. Now similarly we can draw for enable high. Just pay attention again. The only difference will come in enable part. So you are having 1 to 2 decoder here, 1 to 2 decoder here with high enable. You can say high enable, right? We are having one input, pass it through, and output will be 2. Now, right now you are having A. You can pass it through an invert gate here and provide an enable here. The same A can go to here. This will be B. This will be B. Now when A is equal to 0, now this is active high enable. Now when A is equal to 0, 0 will come here. So this will not get activated. The second one will not get activated. And this higher one will get 1 here because this is a NOT gate. So this will get activated. Now for suitable combination of if B is equal to 0, you will get D0. If B is equal to 1, you will get D1. Similarly, when A is equal to 1, you will get 0 here. Then this will not get activated. When A is equal to 1, you will get 1 here. And then this second will be activated. And when B is equal to 0 and A is equal to 1, you will get D2. When B is equal to 1, A is equal to 1, you will get D3. So this is, you can write here 1 to 2 decoder, 1 to 2 decoder. So this is again, we have drawn 2 to 4 decoder using 1 to 2 decoder with active high enable. So this is, we have seen how you can make 2 to 4 decoder using active high and active low using 1 to 2 decoder, right? Now next, we will realize 3 to 8 decoder using 2 to 4 decoder. Just pay attention. Here it has not been mentioned whether you can use active high or active low. So we will see what we can use. So right now what you see here, you have to make 3 to 8 decoder. That means you should have 3 input lines and 8 output lines. But right now you are having only 2 to 4 decoder. So you can use only 2 to 4 decoder to represent 3 to 4 decoder. How you can do this? You can make a truth table, that is A, B, and C. For 3 possible combinations, you will get D0, D1, D2, D3 till D7, right? For 0, 0, 0, D0 will be high, all will be 0. For 0, 0, 1, D1 will be high, all will be low. Similarly, for last case, that is 1, 1, 1, D7 will be high, all will be 0, right? Now you have, it has been given that you are only having 2 to 4 decoder. So 2 to 4 decoder I will draw. Let us say this is 2 to 4 decoder. We are having 2 input lines, 4 output lines. you want 8 output lines, so ultimately you have to use 2 to 4 decoder twice because you want 8 output lines. So here you can see you are having 8 output lines, 4 output lines are here, 4 output lines are here, 2 input lines are here. So you can write here B and C. Now you want enable circuit. For, let us suppose we are using active low enable. So for active low enable, you have to put a circle here. Let us say E and E bar. And this is the MSB, that is A, you can say A is MSB, and pass it through here. And use an invert gate, pass it through here. So when A is equal to 1, you will get 1 here. So this will not get activated. This is, you will get 0 here. So this will get activated. And when B is equal to 0 and C is equal to 0, so A is equal to 1, B is equal to 0, C is equal to 0. That means you will get 1 0 0. That is D4 line will be activated. Next combination, if you want to see, when A is equal to 1, B is equal to 1, C is equal to 1. When A is equal to 1, B is equal to 1, and C is equal to 1, this D7 line will be get activated. Now let us suppose that A is equal to 0. So here you will get here is 1. This will not get activated, but here you will get 0. So this decoder will get activated. Now say B is equal to 0 and C is equal to 0. Now when A is equal to 0, B is equal to 0 and C is equal to 0, you will get D0. When A is equal to 0, let us say B is equal to 1 and C is equal to 1. Now when A is equal to 0, B is equal to 1 and C is equal to 1, you will get D3. Similarly, you can do it for the rest of the combination. So this is what we have drawn, 3 to 8 decoder using 2 to 4 decoder with active low enable. Now, if you wanted to draw it with active high enable, what you could have done, you could have just for active high enable, I'm drawing with green line. You can use here invert gate and pass it through here, and this without invert gate it will come here. With this is for active, green line shows for active high enable, right? In active high enable, obviously this circle will not be there, only E will be there. So this is what we have seen, 3 to 8 decoder using 2 to 4 decoder. So this is the process. You have to draw the truth table, and then you have to draw this logic circuit. Next problem we will see. Realize 4 to 16 decoder using 2 to 4 decoder. So what you have to do here, just check. You have to make, ultimately you have to make 4 to 16 decoder, but right now you are only having 2 to 4 decoder, right? So in output, you, how many lines you want? You want 16 lines, right? But you are only having 2 to 4 decoders. So you will, how many 2 to 4 decoder you will be requiring to represent the output? Right now you will be requiring 4 2 to 4 decoder. So 4 decoder we have made here. I can pass it 4 outputs, 4 outputs, 4 outputs, and 4 outputs. So this is 2 to 4. I can write here decoder, 2 to 4 decoder, 2 to 4 decoder, 2 to 4 decoder. So right now we have made 4 output lines. Provide 2 input here. This can be B, C. Sorry, in four variables. So you are having 4 inputs. So you will have 4 variables, that is A, B, C, D. So least significant is C and D here. So I will write here CD, CD. In all of them, CD is showing, and CD. Right now, you require AB as well. So what I can do, I can use again 2 to 4 decoder here, and provide here AB, and output of this will be here. One combination will be 0 0 0 1 1 0 1 1, right? And output of this all I can make it flow through here, where this is enable high. Just pay attention. So enable high. Right now, for example, let us suppose that we are choosing a is equal to 0 and b is equal to 0. When both of these are 0, this d0 line will be high. This d0 line will be high for this combination. When a is equal to 0, b is equal to 1, this d1 line will be high. When a is equal to 1, b is equal to 0, then this d2 line will be high. When a is equal to 0, b is equal to, sorry, when a is equal to 1, b is equal to 1, this d3 line will be high. For example, let us just consider when a and b both are 0, then in that case, this d0 line will be high and all the line will be low. If d0 line will be high, that means this decoder will get activated, right? Then possible combination of C can be 0, 1, and here also D can have 0, 1. Let us suppose we are having 0, 0, and A and B are both 0, 0. So we will get 0, 0, 0, 0. That is D0 line will be high. If D is equal to 1, then we will get 0, 0, 0, 1. Here 0, 0, 1, 0, 0, 0, 1, 1. So here we will get D1, D2, D3. Now for similarly for second, if we are having, let us say for second case, if you are having A is equal to 0 and B is equal to 1 here, then this D1 will be high and all will be low, and this will be activated. So you can provide here 0 and 0. So 0, 0, 1, 0. Sorry, you will have 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. So this will be D4, D5, D6, and D7. Similarly, for rest of the cases, you can say for A is equal to 1, B is equal to 0, you can make the possible combination. For A is equal to 1, B is equal to 1, you can make the possible combination. So here you can see for realizing 4 to 16 decoder using 2 to 4 decoder, how many 2 to 4 decoder we are requiring? 5. We are requiring total 2 to 4 decoder requirement is 5. So in general, if you want to realize any decoder for lesser input decoder, so you can see like here, if you want to design 4 to 6 decoder using 2 to 4 decoder, then if you want to calculate how many decoders you will be requiring, suppose in MCQ question there is one question where you want to calculate how many lower input decoders you will be requiring to make higher input decoders. So what you can do, you can divide the output of the higher and lower one. For example, here 16 is there and 4 is there. So 16 divided by 4. So this will give me 4. The 4 inputs are still there. So if you can see 4 is still divisible by 4, so I can divide 4 divided by 4 again. So I will get 1 here. So you can add this 4 and 1. So how many gates we will be repairing? We will be repairing as 5 2 to 4 decoder. Just wait. Now, for example, if I ask how many 2 to 4 decoder are required to realize 10 to 1024 decoder. So you can see here what you want to realize. You want to realize 10 to 1024 decoder, but right now you're only having 2 to 4 decoder in your hand. So you want to calculate how many 2 to 4 decoder will be required. So how you can proceed? You can see the output lines here are of lower decoder are 4. The output lines of here higher decoder are 1024. So you have to divide the output lines, and you have to keep dividing till it is either it is not divisible or you are getting 1, right? You have to keep dividing. So 1024 divided by 4. How much you will get? 256. So 256 again you have to divide it by 4. So you will get 6, 4. Just correct me if I don't. So 64 again divided by 4. So how much you will get? 16. Okay. Then 16 again divisible by 4. So 4, and 4 is again divisible by 4. So you will get 1. So add all of this. So if you add this will be 320, 340, and 341. So 341 2 to 4 decoder you will be requiring to make 10 to 1024 decoder. Right? So this is one example. For let us say one more example we will take. How many 3 to 8 decoder will be required to realize 6 to 64 decoder? So you can see you want to make finally 6 to 64 decoder, but right now you are only having in your hand is 3 to 8 decoder. So you can only use 3 to 8 decoder, but you want to realize 3 to 64 decoder. So just see the output lines. Here it is 64, it is 8. You can divide 64 divided by 8. So you will get 8, and 8 again is divisible by 8. So you will get 1. So total you can add this. So 9 decoders, 9 3 to 8 decoders you will require. Is it okay?
Yes, sir.
Okay. Now time is there. Yes, time is. So last topic I will cover. One more topic is there. Am I audible?
Yes, sir.
Okay. So we are having BCD to 7 segment decoders. So basically it is an letters, you can say LED numbers that you are having. So it is used to represent that. There is 7 segment decoder. So in LED which is used to represent the numbers in digital clocks. I will just draw that. So let us suppose this is first LED, and this is second, this is third, this is fourth, fifth, sixth, and seventh. Let I number them. If I number them, this A, B, C, D, E, and F, and this is G. These are all LEDs. Consider that these are LEDs. This will glow. This will glow depending on whatever number you want. So let us suppose if you want 0. So 0, you can say how you can get 0 as this, and this. Right? For glowing 0, how many LEDs you will be requiring? A, B, C, D, E, F, and G is remaining low. Right? If you want to represent 9, right? 9, then in that case, this will be high, 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 and this will be high. So you can say you have represented 9 here. Here you have represented 0. Are you getting the point? Similarly, if you want to represent 6, so what you can do? Like this. This is how 6 is represented in digital. So this will be required to switch it on. So this all should be high. That is A, F, G, E, C, and D. So for this, we want to make a logic such that these should glow ranging from starting from 0 till 9, right? So you want to display sometimes you want to display 0, sometimes you want to display 1, 2, 3, and sometimes you want to display 9. So you can see that is why it is called as BCD, because it is having maximum number as 9, minimum number as 0, and 7 segment decoder means, so you can count here, there are 7 segments, A, B, 1, 2, 3, 4, 5, 6, and 7, right? So there are 7 LEDs which you want possible combinations for the 7 segments LEDs. So to glow this number, right? I will make the truth table first. Let us say we are having decimal number. Decimal number can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we are having BCD. So BCD we can write A3, A2, A1, and A0. 4-bit BCD are there. And then we are having 7 segment LEDs, that is A, B, C, D, E, F, G. Now for getting 0, possible combination will be 0 0 0 0 or 1 0 0 0 1 for 2 0 0 1 0 for 3 0 0 1 1 4 0 1 0 0 5 0 1 0 1 6 0 1 1 0 7 0 1 1 1 8 1 0 0 0 and 9 1 0 0 1. Now tell me, for 0, which LED should be high?
All except G.
All except Z, correct? So I can write here all will be high, 1 1 1 1 1 0, right? Now for 1,
B and C.
B and C, correct? For 1 B and C, so I can write here B and C is high, all will be 0. For 2,
All except F and C.
Yes, sir.
2, I think 2 will be like this, right?
F and
Just
C will
two.
be off.
F and C will be off, correct? F and C will be off. So F will be off and C will be off. All will remain high. Now for 3, 3 will be like this. Just see 3. E and F will be off. E and F will be off. Rest will remain high. Now for 4, 4 will be like this. 4 will be like this. Just see.
AD of.
So A, D, E are off. A, D, and E. A, D, and E are off. Rest are high. Are you getting this or not?
Yes, sir.
Okay. Now for 5,
B and E will be off.
E of.
5 will be like this. B and E will be off, correct? B and E are off. Rest are high. 6,
B off.
6 is only B off. Rest will be high. 7,
A, B and C will be on.
7 will be like this. So A, B, C are high, but only A, B, C are high. A, B, C are high. All will be 0. Then we are having 8.
All high.
All will be high.
All will be high, correct? 1 1 1 1 1 1 1 and 9.
E will be off.
9 will be like this, right? 9 will be like this. So for 9 only E will be off, correct? So E is, I think, this. Just check. Yes, all will be high. Right. Now you want to make the logic for all of these, that is small a, b, c, d, e. Small a, b, c, d, e, f, g, you have to make logic, right? And so possible combinations of inputs are 4. You can see here 4 inputs are there. So possible combination can go up to 16, that is up to 15. But right now you have only used till 9. So that is 10, 11, 12, 13, 14, 15 are your don't cares. That is cross, right? Now for A, now for B, let's say if you want to write our minterms. So B, if you want to write our minterms, so just see what are the minterms for B. These are the minterms for B. That is for 0 to 4. 0, 1, 2, 3, and 4. And then this is 7, 8, 9. So 7, 8, and 9. Plus don't cares are there. There is 10, 11, 12, 13, 14, 15. So you can make a K-map fast. Let me do it. So this will be A3, A2, A1, A0, 00, 01, 11, 10, 00, 01, 11, 10. So 0, 1, 2, 3. Just see where to put 0, 1, 2, 3. So 0, 1, 2, 3 is 0, 1, 2, 3, and 4 will be here. and 7, 8, 9. So 7, 8, 9 will be here. Then 10. Have I made any mistakes? 8, 9. So 7 will be here. Where? 7 will be here. 7, 8, 9. 10 is not there. Sorry. 10 is not there. 7, 8, 9 only is there. Then 10, 11, 12, 13, 14, 15. This is don't care. Now tell me how you will group them. Isolated cells are there. Can I group it like this? Just check. Just see whether I can group it like this or not. Then B will be equal to.
So
I'm
there is
having-
one. So there is one left there. At
Where
cell
one is
number, cell number 9.
Okay.
So we can form an octet there with 0, 1, 2, 3, and 8, 9, 10, 11.
Okay. So that this will not be there. So this you are saying.
Yes, sir.
Okay. So this will be equal to what? This will be equal to A2 bar plus A1 bar.
Sir, we have next class also.
Yes, just a second. A1 bar, A0 bar, A1 and A0, right? So similarly, you can have for combination for A, B, C, D, E, F, G, and E. All the combinations you can get from K-map. And once you get the combination, you can make a simply block diagram where you can pass A0, A1, A2, and A3. Here you can have A, B, C, D, E, F, G, 7 combination 1, 2, 3, 4, 5, 6, 7, and you can have 8 LED blinkers, 7 LED blinkers, and even pass the respective blinkers to them. It is A will be blowing through here, B was going to here, C was going to here, D was going to here, E was going to here, F was going to here, and G was going to here, right? This you can draw after drawing the K-map for all the cases that you can try it by your own. So we will stop here. Our syllabus till midterm is complete.